All right, so the part we need to look at is probability and relative frequency. This is not in our textbook, but it is in our syllabus document, that we need to be able to find probabilities with our relative frequencies. So basically what we're looking at is we're looking at finding probabilities of an event where we've got some data that has been collected over a long period of time. Okay, it's been put in a relative frequency table and we have a look at it. Okay, so first... Right. So, a definition, not the best quality there, but a definition basically for relative frequency probability. So it's a method of calculating probability where the probability is a ratio of the number of trials where the desired effect occurs to the total number of trials. So basically what we're looking at is here in the formula section here is the probability of event E. So our probability notation there, P of E, can be found by the probability is the number of times E occurs divided by the number of trials. So we've got some information and tables, some data that has been collected over a period of time, and we want to know, well, what is the probability of this event occurring, given the data that we've got saved. Okay, so here is an example. Titanic. Okay, we've got morbid. Some people survived, but... So we're only looking at passengers here. We've got some data about the passengers. We know nothing about those people who were part of the crew. So this particular data in this table have first class passengers, second class passengers, third class passengers. We have information about who survived and information about who died. So our question down here says, assuming that one of the 1,316 passengers is randomly selected, find the probability, so find the probability that it is a passenger who survived. So we're going to pick a person, any person. What is the probability that the person survived? It's not that morbid. I could choose much worse things. Okay. So, the probability that they survived. In fact, what we should have is we should have that as a squiggly line, not as an equal sign, because it's approximately equal to. So we're going to have a ratio, some kind of fraction. First of all, we want to know the total that we have. What is the total? We don't even have to add that up there. It's given to us here in the question, 1,316. Okay, so one of these 1,316 people are chosen. What is the probability that they survive? What we need to do then is look at adding up these numbers here. And I haven't done that, so what is it? What, sorry? Little human calculator in the back. 498. So 498 people in this table are survivors. So we've got 498 divided by 1,316. So if we do that on our calculator, that's approximately equal to 0.334. Say again? 3.
Just 3.
What we need to do is, it's really important if we use 3 decimal places.
0.378.
So if we take it to 3 decimal places, we can then say, well, that's approximately 38%. Because percent means per 100. So we'd be looking at timesing this by 100 and we'd get about 38%. Okay, so the probability that at one of these 1,316 people chosen is a survivor is 0.378 or about 38%. Okay, what have we done here? We looked at the total that we have, the total number that we have as the denominator, and the number on the top, the numerator, is the number that we're interested in, the probability of that event. And what was the event? That they survived. Okay, that is what our relative frequency is. You've looked at relative frequency tables before, and I would imagine you've looked at relative frequency with probability since year 9. Okay, I know last year I taught my year 9s this. Right, so